Okay, here we are proving that the left-hand side is equal to tan 2x, which is going to be sine 2x all over cos 2x. So we want the left-hand side. It's important to always write proof, and then we are choosing the left-hand side. So the left-hand side, we'll write it first as cos x over cos x minus sine x, then minus cos x all over cos x plus sine x. Now the LCD here is going to be all of this, which is cos x minus sine x, then multiply by this, which is cos of x plus sine of x. So the cos x minus sine x will cancel cos x minus sine x, and then we'll remain with cos x plus sine x, which is this. Then we times it with the cos x. And then now this, we bring the negative down. The cos x plus sine x will cancel itself here. Then we'll remain with the cos x minus sine x times cos this one. It is important to write all of these times with cos and these times with cos, putting them in brackets. Now we are going to multiply everything. Cos times cos is going to be cos squared x, and then cos times sine is going to be sine x cos x. And then here, pay attention to the negative. I'm going to times all of these first. Then cos times cos is cos squared x, then cos times minus sine is minus sine x cos x. And then here, cos times cos is going to be cos squared x, and then cos times sine is going to be plus sine x cos x. Then minus sine times cos is going to be minus sine x cos x. Then minus sine times plus sine is going to be negative, not positive. It's going to be negative as sine squared x. Then from there we are looking, we are bringing back everything. We're bringing back the cos squared x plus sine x cos x. Now here the bracket means we multiply. Negative times cos squared is going to be negative cos squared x. The negative times negative is positive sine x cos x. Now all over here we look, we have cos squared x, and then we see that the sine x cos x is the same with this sine x cos x, and they have different signs, so they will subtract each out, and then we are remaining with sine squared x. And then we continue. Here we see that the cos squared x and this negative cos squared x are the same but with different signs. They subtract each out. Then the sine x cos x is the same with that one, so we add them. There are two. It's going to be 2 sine x cos x. Now all over cos squared x minus sine squared x. And then we look where we started. We said that tan 2x is going to be equals to sine 2x over cos 2x. Now here we see that this is the double angle. So we write the 2 sine x cos x as a sine 2x all over. The cos squared x minus sine squared x, we know that it is cos 2x, which is what we said in the beginning that we wanted. So this is exactly what we have as tan 2x. So now we can then write that this is equal to the right hand side, and then conclude that the left hand side is equal to the right-hand side. Things to note is that every time you are doing this, you have to be careful of this minus. That this minus is going to multiply everything, like you see here, minus times cos squared, and then giving us the negative cos, and then the negative times negative, giving us a plus. That one is very important. Another thing is that here we see that these things, the like terms are separating themselves out, and then we see that they are adding. And then from there we see that we just have to recognize that this is indeed a double angle.